All right, this is an overview of the lab that we're going to do tomorrow. Basically, we're going to do gravimetrical analysis. An example of what you see is what's called water hardness. There's calcium that builds up in water. There's an ion, basically calcium that floats up in water. And one of the things is you build up calcium carbonate, and that's what you see when they talk about hard water. That's one of the things that ends up precipitating out and causes deposits to form in pipes and other appliances. The other thing is you may see soap scum, like this example of soap scum sometimes in your shower, because what happens is calcium reacts with another ion that basically produces soap scum. So what that is that's like gravimetrical analysis as well, or it's a precipitate reaction. So what we're going to do is we're going to do a simulation of the formation of calcium carbonate to figure out how much calcium is in solution. So what you're going to get tomorrow is you're going to get a bunch of beakers, and they're going to they'll have different amounts of calcium ion in there. So I'm going to dissolve different amounts of calcium in each one. You'll have different preps. And the idea behind it is we're going to add the other component to this. So we're going to add Na2CO3. Well, we know that Na plus is always soluble. CO3 minus is not always soluble. So really by adding Na2CO3, we're really just going to be adding CO3 2 minus and Ca, which will produce a precipitate. The idea is the precipitate will sink down to the bottom, and then we're going to measure how much we get, and that's what gravimetrical analysis really is using one ion to knock another ion out of solution. So in this case, the sodium carbonate, we're really using the carbonate ion to knock it out. Now here's some key things you'll have to do. One of the things we may do, we may either just use regular filter paper, I may try and set up in a sink what's called vacuum filtration. That's where you hook up an aspirator to a sink and you let water flow, which creates a vacuum. So you take your precipitate and you can actually filter the water because we want to get the water out of it. You basically can pour your solution. The water should pour through. There's a filter in here. And then what happens is it creates a vacuum, and then you'll basically have your dried, or not your dried, but your CaCO3 solid would be left in the funnel afterwards. If not, we'll just use the standard ring stand and funnel, depending on if I can set it up or not. But ultimately, before you go in to do the lab, there's some pre-lab calculations you have to be able to do. So you'll have this table. You want to basically put this table in your lab book. So I will post the PDF online so you can print it out, cut this table out, put it in your lab book. The first thing is your group will only get 3 samples. You're not going to do all 6 because we're going to basically put all the class data together. So your group will have 3 samples. The first thing you have to calculate is the moles of Ca2 plus in solution. I'm giving you the molarity, and you're always going to be using 20 milliliters. So remember, to get moles, it's M times L will always give us moles of an ion in solution. So in this case, well, I'll do a sample. So I'm going to take 20 milliliters, which is the same thing as 0.020 liters. And then I know my molarity for solution 1 would be 0.400. And I'm going to multiply that. Ultimately, I'm going to get 0.0080 moles of Ca2 plus. So I would put 0.0080 there. First one's done. Second thing they want you to do is calculate the theoretical amount of the precipitate that you're going to generate. If you look back at our reaction, it's a 1-to-1 ratio, produces one of those. Our limiting reactant, we're going to pour in excess. So we're going to make sure that we pour in extra CO3 to knock out every single calcium ion to make sure it goes down. So our limiting reactant we know for sure is a calcium. So basically, to calculate the theoretical amount of the precipitate, so we did this, this is the ion calculation we already did, the moles. It says basically figure out the theoretical, so we have to figure out what the theoretical yield will be. So what we'll do is we're going to take a grid, we'll do the same kind of grid each time. And what I'm going to do is I'll do the grid for the first one. So the first amount that I'm starting with is going to be 20, it's always going to be 20 milliliters. So I'm going to go 0.020 liters of Ca2 plus. When liters of Ca2 plus is here, what has to go down there? That's where I'm going to use the molarity. So my molarity right there is 0.400. So I'm going to say 1 liter is 0.400 moles of Ca2 plus. And what do I know from the equation? Well, 1 mole of Ca2 plus, this is my limiting reactant, is going to be equal to 1 mole of CaCO3. And then 1 mole of CaCO3 is equal to 100.1 grams of CaCO3. So I'm going to basically run that grid. When I run that grid, I'm going to get 0.801 grams of CaCO3. That means if I knock out every single calcium ion in there, when I weigh out my precipitate, when it dries, it should weigh 0.1 or 0.801 grams. So I would go back to the table here. 0.801 grams would be my theoretical yield. Now, how do we make sure that the calcium is the limiting reactant? We're going to actually add excess Na2CO3. So we have to calculate how much excess we would use for each one. How are you going to do that calculation? Well, when you do that calculation, we're going to multiply the amount that we're required to neutralize it, and we're going to multiply it times 1.2 to provide a 20% excess to make sure that we have the amount needed to definitely knock out the calcium. So I'm going to start with the moles. So I'm going to use the moles from this part of the table, and I'm going to go 0.0080 moles of Ca2 plus. Okay? Well, what's my reaction? My reaction is 1 mole of Ca2 plus reacts with 1 mole of CO3 2 minus. And what do I know? Well, I know the molarity. The molarity of sodium carbonate that we're using is 0.5 molar Na2CO3. So what does that mean, really? 5 moles of CO3 here, and it's basically Na2CO3 is the same thing as CO3 minus. So I'm going to use the molarity. I'm going to say 0.5 moles in 1 liter. So I just took the molarity, dropped it there. This is my turkey or my mole ratio. I have my moles of calcium to make sure I knock them all out. When I multiply this all the way across, I will get a number. I get 0.016 liters. That's how much would be required to exactly knock out all the calcium. But I want to make sure I definitely do it. So I'm going to multiply that times 1.2. So I'm going to go 0.016 liters times a factor of 1.2, and that means I'm going to end up getting 0.192 liters. So I have to basically, if I want to change this to milliliters, I'm going to basically whoops, I forgot a zero there, I think. 0.019, so it's basically when I divide by 1,000, I'm going to get 19.2 milliliters is the amount I should put in. So when I come back here to this data table, I'm going to come over here and I'm going to say, okay, I need to add 19.2 milliliters to completely knock it out. The last thing is to calculate what's called the theoretical water hardness. So the actual hardness of water, how much calcium is in there, and we do it milligrams per liter. Well, if we already have our theoretical amount we're supposed to get based on what we know is in there, so if we look here, we're supposed to get 801 grams. That's all what we're supposed to do, so we'll use that. So when we go to calculate the theoretical yield, what I'm going to do is I'm going to start with my theoretical yield, which is 0.081 grams of CaCO3 in 0.020 liters. What I have to do is convert from grams. See how I have grams here? I need it in milligrams, basically, per liter. So what do I do? Well, I use the metric system. What do I know? I know that 1 gram is equal to 1,000 milligrams. And then the last thing is the sample that we used had been concentrated by a factor of 100. So the actual sample that we use had been concentrated by a factor of 100. So the actual value is going to be 1/100th of that. So all I do to return it to the actual value is I'm just going to multiply times 1 over, or basically divide by 100. So when I multiply that thing all the way through, multiply this all the way through, I end up getting 400 milligrams of calcium, 400 milligrams for calcium per milliliter. And that's how I do my calculation. So I take my theoretical yield. This is the theoretical yield. I showed you how to solve for it earlier. I take my metric conversion right there, and then I multiply my factor, since the solution was concentrated by a factor of 100 more than normal water is. You would multiply times 1 over 1 divided by 100, and you basically get 400 milligrams. And I come back here, and I get 400. Theoretically, I have 400 milligrams per liter, which would determine how hard the water is. I think there's a chart here. I don't know if I put the chart in there. In your lab, there's a chart that determines water hardness. Ultimately, here's what we're basically going to do. We're going to start with some calcium. You have to tell me how many moles. That's M times L. We'll always get moles of Ca2+. We're going to add excess CO3. So we're going to take all the Ca2 pluses. You're basically going to pour sodium carbonate in there. You're going to knock all the Cas and turn them into CO3s. You're going to turn it into solids. So in the end, there is no more calcium floating around. There will be some excess. There will be some excess carbonate, so CO3 2 minus will be left over, and of course the Na that is already in there, Na plus, spectator ion, will be floating around the beaker. And ultimately, we're trying to find out what the mass of this is, the theoretical yield. Then we're going to dry it, we'll filter it, dry it, and then calculate out. We're able to calculate out the hardness of water. So what you need to do for homework is you need to finish this chart, do the calculations. I wouldn't be surprised if I gave you one of these like on a pop quiz before you did the lab. I would give you one value, expect you to do this, 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 and this. So if you have trouble following the calculations, rewind the video and make sure that you can do it in case I ask you to do one before you start your lab, which is a distinct possibility. Last thing you want to do is you'll set up your lab book. You can kind of describe the procedure. Basically, what you're going to do is pour one solution into another with a beaker, filtrate it out. I'll let you create your procedure in numbered steps. After you create your procedure, you'll have the data table that you just calculated, and then this is our actual data table for the lab. We'll get our results that we measure. We'll see what our percent yield is based on our amount that we actually mass compared to the theoretical yield, and then we'll actually be able to calculate water hardness the exact same way. So you would create a table like this in your lab book. So when we go to do our lab book, key things you want to set up for tomorrow, you would do this. You would set up with, you'd obviously have your title, plug in your title. You would have your purpose, which based on this video, you should be able to explain what the whole thing is that we're doing. The purpose, you are creating a modified procedure based on what I described that we're going to do, numbered, and then basically you'll have your first table of calculations. So the first table of the calculated pre-lab values will be in there. You'll scan it, upload it into Turnitin.com and bring it with you. And then the other thing you'll do is create, just past that, you'll create a data table for the lab when we actually do it tomorrow. All right, have a good evening. Hope the video helped with the lab calculations. See you tomorrow.